Fusion Mobile, quality e-learning experience on the go.
For our class today, we'll be talking about number systems, number systems. And we'll be having our focus on binary numbers. We'll be focusing on binary numbers. Binary numbers. Alright. There are various number systems you have. There are various number systems you have in mathematics, and basically mathematics has to do with dealing with digits. And the common number system we know and we encounter in our daily mathematics or daily life mathematics is called the decimal form of numbers. The decimal form of numbers. Okay, this decimal form of numbers is also called the denary numbering system, or the denary system of numbering. Denary system of numbering. Alright, you can as well call it the base 10 numbers, or we'll call the base 10 numbers. Okay, these numbers, they consist of digits ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. I know you will be surprised why we didn't include the 10th digit being 10. Okay, remember we said they contain how many digits? They have 9 good digits, ranging from 0 is a digit, and then to the last digit you have the 9. Why we say we encounter them in our everyday life is because for all other numbers you can see in your multiple table or in your numbers, they are consisted using numbers from the denary. From the denary you can obtain numbers like 89, you can obtain numbers like 88, you can obtain numbers like 79, you can obtain numbers like 100. Okay, alright, this is an example of what we call denary numbers. There are other number systems. We have the octal numbers, the octal numbers. Have the octal numbers. Okay, good. These numbers consist of 8 digits, and it ranges from 0, 1, 2, 3, 4, 5, 6 and 7. Okay, and as well the 8th digit is not included in the octal numbers. The 8th digit is not included in the octal numbers. Alright, we have another system of numbering we call the hexal numbers. We have the hexal numbers. The hexal numbers. Okay, they consist of digits like 0, 1, 2, 3, 4 and 5. Okay, alright, the hexal numbers have 6 digits, and that's why you have 0, 1, 2, 3, and the 6th number is not included. Okay, the maximum of the octal numbers can be of an example like 77. It is an octal number. You can have combination of octal numbers like 6, 7, 6, 5 and any other combination you can think about, but numbers must range within the octal numbers. The numbers must range within the octal numbers. And just like in hexal numbers too, you can have combinations of the form of 55, you can have 5, 4, 3 and any other combination of numbers you can think about. Alright, other number systems are formed using this method, a combination of this method. Okay, we have the hexadecimal numbers. We have the hexadecimal numbers, okay, which has to do with a combination of hexal numbers and decimal numbers. And when you combine the two of them, you will be having how many digits? You'll be having 6 plus 10, and it will be giving you how many digits? That's 16 digits. And you can write it ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 10 digits. and then the 11 digit starts as A, B, C, D, E, and F, giving you 16 digits in all, where A stands for 10 and B stands for 11 and C respectively. They follow in that method too. The same thing happens to octadecimal numbers. Octadecimal numbers, you have digits consisting of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th digit is the A. You have the 10th digit is the 9th. Is the digit 9, and the 11th digit there is the A. The 12th digit is B. The 13th digit C, and it follows that way. 14, 15, E, 16, 17, and then 18. All right. There are other number systems. But they are for higher levels, not for the purpose of this study. Okay. And the other number system we'll be talking about basically that is important for this study is called the binary numbers. You can as well call them base 2 numbers. All right. They consist of just 2 digits, and the 2 digits are zeros and 1. Right. So any other combination of these could include numbers like 100, 101, 111, and so on. Now in the next slide we'll be talking about how to convert numbers, conversion of binary numbers, Alright, talking about conversion of binary numbers. Alright, in conversion of binary numbers, you can convert base 2 numbers to base 10 numbers, and you can convert base 10 numbers to base 2 numbers. There are 2 methods for converting from base 2 numbers to base 10. You can as well convert other bases to base 10 numbers. The 2 methods I could think about, the first method is I call the method of indices and expansion. Method of indices and expansion. All right, and then the second method is the one I call the method of repeated multiplication and addition. Method of repeated multiplication and addition. All right, these are the 2 important methods you can use to convert from any base at all to base 10. Okay, they are both used to convert from any base at all to base 10. Any base at all to base 10. All right, we'll be taking our first example. Assuming we want to convert the following numbers. I will take 2 examples for this section. Assuming we want to convert the following numbers, like you're told to convert A. You have 25024 in base 6, and B you have 1001 in base 2, and you are told to convert these 2 to base 10. All right, now there are methods that could help you execute this without making so many mistakes. The first thing you do is, for our first example A, for which the base number is 6. The base number is 6, and we intend to convert to base 10, the base 10 according to the instruction. All right, the first thing we do is to start numbering the digits we intend to convert, the digits of the base 6 numbers, starting from the right hand side. This is my right hand side, and I give it the first number as 0, giving it a superscript number 0, and the next I give a superscript number as 1. I give this a superscript number of 2, I give this a superscript number of 3, and I give this a superscript number of 4. It's just like you're numbering them starting from the right hand side, and then you are numbering them in an ascending order, just starting from your right hand side. Good, you will have this. Now what you do next is to multiply each digit as numbered by the base number raised to the power of each superscript. Remember, this is what we call the superscript. The superscript of 4 is the 0, the superscript of 2 is the 1, the superscript of 0 here is 2, and the superscript of 5 here is 3, and the superscript of 2 here is 4. All right, and we say you have to multiply each base number. You have to multiply each base number raised to the superscript by each digit. All right, the first digit we have there is 4. Okay, and the base number and their base number is 6. Okay, and the superscript on 4 is 0. All right, so we have 4 times 6 raised to power 0, and then you add, because we are using the method of indices and expansion. That is why we are adding. Sorry, we are using the method 2, the one we called a method of repeated multiplication. Method of repeated multiplication, that's what we are applying right now. That is why you have us multiplying and adding. All right, and then the next number there is 2. All right, 2 multiplied by the base number 6 raised to the power of each superscript 1, and then the next number there is 0 multiplied by the base number 6 raised to each superscript there is 2, and then you add again. You have the next digit there as 5 being multiplied by the base number 6 with each superscript as 3, and then you have the next digit there as 2 being multiplied by the base number 6 with each superscript 4. All right, so what do we do the next step? You see, remember that any number raised to the power 0 is given the value 1 from your indices. We'll still talk about indices in our next topic, so don't get bothered when we talk about indices here. I'm just using this illustration, but just have it in mind that any number that is raised to the power of 6, any number that is raised to the power of 0 rather, is termed to be equal to 1. The proofs will come later in previous classes, in further classes. And we have 4 times, that means 6 raised to power 0 is written as 1, plus 2 times 6 raised to power 1 is 6. All right, plus 0. You know that ordinarily anything multiplied by 0 is 0, so we just write down 0 here. Then plus 5 times 6 raised to the power 3. 6 raised to the power 3 will 6 raised to the power 3 we have as that is 6 times 6. 6 times 6 which gives us 36. Sorry, we'll have to do some rough works here. I have to do some rough works here. I have 6 times 6 to be 36 times another 6, and then you have 6 times 6 36. 6 times 3 you have 18 plus your 3, that is 18 plus 3, which gives you 21. You have 216. All right, so that means we have 5 times 6 raised to the power 3, and we know that 5 times 6 raised to the power 3 is 216. We'll write on the next slide, and then let me include these two, plus you have 2 times 6 raised to the power 4. Alright, all this will come up in the next slide. Alright, 4 times 1 is 4, and we add up, and then the next digit there we have is 2 times 6, which we know is 12, and then the next digit we have there is 0 times 6, like we had previously. Raised to the power 2 is 0, and then from the slide gone, we had 5 times 6 raised to the power 6 raised to the power 3, and 6 raised to the power 3 we obtained to be equal to 2, 1, and 6. Alright, good. And then the next digit there we have 2 times 6 raised to the power 4, which is as good as saying 2 times which is as good as saying 2 times I multiply this by 6 to add up. You have 6, you have 3 here, and then 6 times 1 is 6, plus 3 you have 9, and 6 times 2 is 12, and then you have 1, 2, 9, 6. Alright, I could add up to give me this 4 plus 12 plus 0 plus 5 times 6 is 30, and 5 times 1 is 5, plus 3 to give me 8, and then 5 times 2 is 10. Alright, plus you have 2 times 6 is 12, you have 2 times 9 as 18, plus 1 19, and then I still carry my 1. 2 times 2 is 4, plus 1 you have 5, and then 2 times 1 is 2. Alright, good. That means from this line we have 4 plus 12 plus 0 plus 1 0 8 0 plus 2 5 9 2. Alright, you can now sum up the numbers to get the actual digits in base 10. 4 plus 12 gives you 16, plus, and this, adding up these two numbers, you have 2 from this point. 8 plus 9 gives you 17, you carry 1. 5 plus 0 is 5, plus 1 you have 6, and then 2 plus 1 gives you 3. Alright, you can now add up 16, and then you have 6 plus 2 to be 8, and you can now add 1 and 7 to give you what, 8 again, and then you bring down your 6, you bring down your 3, and this is the number we have as its base 10 number. So converting, so this implies that that arrow means that it implies, this implies that when you convert 25024 from base 6 to base 10, you have 3688 base 10. And for our second example, for the solution 2, alright, for the solution 2 we have to convert 101 in base 2, we have to convert 1001 in base 2 to base 10. Alright, okay, the same thing we did for the first example, for the previous example, that is what we'll still do for the second example. All you have to do is to bring out the digits you are to convert. Start to number them starting from the right hand side, giving it the least digits 0, 1, 2, and 3. Okay, now you start to multiply them by the superscript numbers. You have 1 multiplied by the base number 2 raised to the superscript number 0, plus you have 0 multiplied by the base number 2 raised to the superscript number 1, and you have 0 again multiplied by the base number 2 raised to the superscript number 2, and you have 1 1 multiplied by the base number 2 raised to the superscript number 3. Alright, on the next line you have 1 times, remember that anything raised to the power 0 previously is 1, plus you have 0 times 2 raised to the power 1 is 2, plus you have 0 times 2 raised to the power 2 is 4, plus you have 1 times 2 raised to the power 3 is 8. I think this example is simpler. Alright, on the next line you have 1 times 1, 0 times 2 is 0, 0 times 4 is 0, and then 1 times 8 is 8. Good. And on the next line we have just 1 and 8 coming through the additions, and the 1 plus 8 gives you 9, and 9 is the number in base 10. So therefore we can say that 1001 raised to base 2 to the base 2 can be changed to the base to its base 10, and it gives 9 base 10. Alright, the other method we'll be talking about is the method of like we said, we have 2 methods, and the other method we'll be talking about the method of indices and expansion. And how we go through this method, we use 2 different examples too, but we'll still try them for converting to base 10 using the other method we use. Alright, the first example I want us to go through is this, using the method of alright, we'll pick an example. Convert this 212 in base 3 to base 10. Okay, the method is simple. And it follows like this. All you have to do is multiply the base number and then add the next digit and continue in that manner till you get to the last digit. Now let's see how you do this. You have 212, sorry, let me include 0 at this point. Alright, so you have 2120 and you have the base of 3 and you intend to convert. Now like I said, the method includes the first digit of the number you intend to convert is 2. Alright, you multiply by the base number, okay, and then 2 times 3 gives you what? 6, and then you add the next digits. The next digits of the number you intend to multiply is 1. When you add it, you have 7, and then you multiply again by your base number. Okay, 3 times 7 is 21. Then you add the next digit. The next digit of the number you intend to convert is 2, and it gives you 23, and you multiply by 3 again. Alright, 3 times 3 gives you 9. 3 times 3 gives you 9, and then 2 times 3 gives you 6. Alright, and the next digit there, which is the last digit, is 0, and at this point 69 plus 0 is equal to 69. At this point when you add the last digit, you stop multiplying by the base number. So therefore we can say that 2120 to the base of 3, if to be converted to base 10, gives 69 base 10. Alright, we can try using the other method. We can try converting this using the first method we used previously. We can as well say convert 2120 to base 3 to using the other method like we mentioned, and then it implies you have 2 1 2 0 base 3, and then numbering from your right hand side, you have 0 1, you have 2, you have 3. All right, the next line follows that you have 2 times 3 to the base number 3. It doesn't really matter where your multiplication starts from. You can start from from multiplying from the left hand side. You can as well start multiplying from the right hand side. It doesn't really matter. What matters is that you straightly follow the superscript numbers attached to each digit. All right, and just like this one, I'm starting from the left hand side. Unlike the previous examples where I started from the right hand side, doesn't really matter. Like I said, when you add the next digits there, you have 1. Okay, 1 times the base number 3 raised to the power of 2. All right, and then the next digit there, you have 2 times the base number 3 raised to the power 1, and then the next digit there you have is 0 times 3, the base number raised to the power 0. All right, okay, the next line follows that you have 2 times 3 raised to the power 3 gives 27. All right, and then 3 raised to the power 2 gives 9, and then 3 raised to the power 1 gives 3, and then 3 raised to the power 0 is 1, like we've emphasized previously. 2 times 27 gives you 2 times 7 is 14, and then you keep your 1. 2 times 2 is 4. You add your 1 and you have 54, plus 9 times 1 is 9. 2 times 3 is 6, and 0 times 1 is 0. All right, now what I normally do is I pick the list numbers, add them up so that they can form 2-digit numbers, and then the computation becomes easier for me. When I add the list numbers here, 9 and 6, 9 plus 6 gives me 15, and then which makes the computation easier for me. I can add 1 to 5 and I have 6. I can add 4 to 5 and I have 9. All right, to base 10. You see that it is the same answer we have from the same method. So therefore, whichever method you use, you will always obtain 2120 base 3 to base 10 as 69 base 10. All right, we'll take one more example and we will talk of how to convert base numbers, base 10 numbers to other bases. Now let's take one more example. Assuming we have to convert base numbers like example 2. Assuming we intend to convert base numbers like we had previously, like 1001 in base 2, and we tend to convert to base 10 using the previous method we used. We have 1001 and 2, okay, and we have to convert to base 10. All right, the first digit there is 1, and when you multiply by 2 you have 2. The next digit is 0. Adding to 2 you have 2. Multiply again by the base number 2, you have 4, and the next digit is 0. When you add to 4 you have 4 again, and then multiply by the base number 2, you have 2 times 4 is 8, and when you add the last digit you have 9. Sorry, the last digit there is 1. When you add to 8 you have 9. Okay, and since there are no other digits beside it, you have to stop at this point. So therefore we can say that 1001 to base 2 written in base 10 form is 9 base 10, just like we obtained previously in the examples we did before using the other method. I think this goes a long way to justify the fact that any of the two methods you use can give you the same outcome. All right, now we'll be talking about how to convert other bases from base 10 numbers to other bases. There is only one method you can use to do this conversion, okay, and that method is the method of continuous division. All right, like I said, converting from base 10 to other bases. All right, for this class we just have one method of doing this conversion, and it's called the method of continuous division. Continuous division. All right, why we call it the method of continuous division is because when you want to convert numbers, okay, all you have to do is to keep dividing till you get 1 as your remainder. Keep dividing till you get 1 as your remainder. Like we mentioned previously, from the conversion we did, for example, the last example we had 2 1 to base 3. Okay, if we convert from base 3 to base 10, you will have 23 base 10. Okay, let's try converting back 23 base 10 to base 3 and see whether we'll have the same outcome. All right, you'll find out that there is a change in how the digits are manipulated. In previous examples, you find out that when we want to convert to base 10, we multiply by the base number of the number you want to convert to base 10, but it's not like that in trying to convert to other bases. All you have to do is to divide by the base number you intend to convert to. Sorry, this should have been base 3, not base 10 again. And so continuous division, this is my division line, okay, and the number I'm going to divide is 23. Okay, and I'm converting to base 3, that's why I'm dividing by 3. 3 cannot divide 23, but 3 can divide 21 to give me 7. Okay, and if 3 divides 21, I will have 2 as my remainder. And 3 cannot divide 7, but it can divide 6, and if 3 divides 6, you have 2, or you have a remainder as 1. Alright, at this point 3 cannot divide 2 because 2 is less than 3, so we stop our division at this point. Alright, now the method of collecting these digits is as drawn with my arrow. You find out that my arrow points from the last digit to the first digit, which implies that you can write as 2 as the last digit, 2 as the last digit, followed by 1 and followed by 2. So the remainders of this division consist of the base number we want to convert to. Okay, you can see a relationship between this and the previous value from which it was converted from. Alright, so as other examples are obtained this way too. You can convert from any digit at all to base 10, and you can convert from base 10 to any digit. Assuming we want to convert 1001 to base 10. Over to the next slide. We have done this exercise previously from base 2 to base 10. Remember we said you keep numbering, and when we did this we had the value as 9 base 10. Now let us try to convert 9 base 10 to base 2. Okay, let us try to convert back 9 base 10 to base 2, and let us use that as our second example for this method of for this method of continuous division. Okay, now all I have to do is to divide 9 through by the digits 2. Okay, and I set up my division. I have 9 on this side, and then I have to divide in 9. Alright, 2 takes on 9, it cannot divide it, but it can divide 8, and it gives you 4, remainder 1. And then 2 takes on 4, it gives you 2, remainder 0, no remainder. And 2 takes on 2, it gives you 1, remainder 0. At this point you find out that 2 cannot divide 1 because 2 is less than 1, and you pick your remainders from this point. Okay, and then you have the conversion to be equal to 1 0 0 and 1. Now in base 2, remember what we said previously when we wanted to start this class. We said that for you to know when you're performing well or when you're not doing well, once you convert any number and the digits that form the base numbers are not in it, then you know you've not gotten it. Assuming we converted this and then we obtained the digits to be equal to 1 2 2 1, then the answer will be wrong. Why? Because 2 is not a base 2 number. Base 2 numbers consist of zeros and ones. Alright, so this is all about converting back from base 10 to different bases. You can use this method to convert to base 6. You can use this method to convert to base 8. Any other base less than base 10, you can use this method to get back to the base digit. Now I'll be talking about how to convert decimal fractions from base 10 to other bases and from other bases to base 10. Talking about converting decimal fractions. Alright, and for our first example, the methods really don't differ. The method really don't differ here, but all you have to do is to be careful with your superscripts. If you find it difficult, do the whole number side separate, and you can do the decimal side separate. For example, assuming we are to convert 1011.1011, assuming we are to convert this to base 10. This is in base 2, convert to base 10. Alright, the method of numbering does not differ. Okay, using the first method, we can number giving superscripts as well. We have 1011 1011 base 2. Okay, I start my numbering at this point because I have a decimal point here. When I start my number at this point, I have 0, I have 1, I have 2, I have 3. Remember what happens in your number line. When you have positive digits on one side, the next side will consist of negative digits, -1, -2, -3 and -4. Okay, writing this elaboratively, I could say what I'm trying to write is this: 0.1 2 1 1. Alright, so I have 3, I have 2, I have 1 0, -1, -2, -3 and -4. Okay, so I can continue with my multiplication and my addition. And it follows like this. The next line we have starting from this point, I'll be moving this way down. Alright, and then I have 1 times the base number, the first number here, 1 times the base number 2 raised to the power what? 3 plus 0 times the base number 2 raised to the power 2 plus 1 times 2 the base number raised to the power 1 plus 1 times 2 the base number raised to the power 0. Okay, the decimal point side continues, and then I have 1 times the base number 2 raised to the power minus 1 plus 0 times the base number 2 raised to the power minus 2 plus you have 1 times the base number 2 raised to the power minus 3, and then the addition continues. On the next line you have 1 times the base number 2 raised to the power minus 4. Okay, and that is where it ends. Alright, and the next line follows that you have 1 times 2 raised to the power 3 is 8, and then remember that anywhere you encounter 0 means that you have 0 as the outcome, and then plus you have 1 times 2 raised to the power 2 raised to the power 1 is 1 plus you have 1 times 2 raised to the power 0, anything raised to the power 0 is 1. Alright, and then you have plus 1 times 2 raised to the power minus 1. This is on an indices form, and you can convert this from an indices form to give you 1 over 2. So I can as well write this as 1 times 1 over 2. Alright, plus I've encountered 0 again on this point, and I have 0 times this, and I know it gives me back 0, because no matter what happens, 0 multiplying any quotient will always give you 0. Alright, 1 times this 2 is in indices form, and if I convert it I have 1 over 2 raised to the power 3. Okay, and then the last digit there takes from 1 times this 2 is in indices form, and if I convert it I have 1 over 2 raised to the power 4. Like I said previously, you don't need to get bothered. Let the word indices not bug you so much, because we still talk about indices in our lessons to come. Okay, the next line follows like this. 1 times 8 is 8. I bring down my 0 plus 2 times 1 is 2 plus 1 times 1 is 1 plus, and then I get to the parts that have an indices. 1 times half is half. Okay, let me just include this, and then I'll get my 0 off. Okay, let me just still keep the 0 plus 1 times 2 raised to the power 3 is as good as saying 1 times 2 raised to the power 3 is 8, and then plus 1 times 1 over 2 raised to the power 4, 1 over 2 raised to the power 4 is 16. Alright, the next line follows like this. I'm eliminating all the zeros I have so that I could reduce space. You have 2, and you have 1 times half is half. Okay, and then I jump to this 1 over 8 2, and then I jump to the next digit. I have 1 over 16. Alright, I add the first 3 whole numbers, and then I have 8 plus 2 10 plus 1 11. Alright, so I can now add the 3 fractional numbers. I can add the 3 fractional numbers. Okay, this is my own method. What I do is this: 1 over 2 plus 1 over 8 plus 1 over 16. LCM here will be 16. Okay, and then 16 divided by 2 is 8, and 16 divided by 8 is 2, and 16 divided by 16 is 1. 1 times 1 is 1. So summing them all together, I have 8 plus 2 plus 1 to give me 11 over 16. Alright, so I have 11 plus 11 over 16, and then the next slide follows. 11 over 16 plus 11. If I want to write in fractional form, I can say this is 11 whole number 11 over 16, okay, as a value. But if I want to write in decimal form, I can write as 11 plus 11 over 16 is 11 over 16 gives, when you divide through, you'll be having an improper fraction already there. You have an improper fraction, and is that, no, it's a proper fraction rather. And then when you divide through, you have a digit, a decimal digit, that gives you 0 points, which gives 0.6875. all right, which means we can write this to be equal to 11.0606875. is that right? No, we can write as 11.6875. right, so we can try converting this digit from base 10. You can try converting this digit from base 10 to base 2 back. Let's see whether we can have the same value we had previously. Now the method is as follows. The method of converting fractions is as follows. Now remember, the conversion to base 10 is easy because of when you denote the numbers using their superscript, okay, but converting back to other bases from base 10 could be a little bit tasking. Now from the last slide, we had 11.6875 as its conversion from base 10, 11.6875 in base 10, and we intend to convert back to base 2. Now the method involved here is that while you do continuous division for the whole number side, you do continuous multiplication for the fractional side. You know, the digits we have here consist of two sides. There is fraction or the decimal side, and then there is a whole number side. The fractional side we have 11, and the whole number side we have 11, rather, whole number 11, and on the fractional side we have 0.6875. right, side of decimal. Okay, now these are the two sides that make up the two numbers. Now for the fractional side, like I said, you will apply continuous division, and for the whole number side, you have to apply continuous multiplication. Alright, now what we do next is this. In the continuous division we did previously, we can easily do this for 11, and then you have, remember, we want to convert to base 2, so 2 will be the divisor, and then 2 dividing 11 cannot easily go, but 2 can divide 10, and when it does that, it gives you 5, and then remainder 1, and 2 divides 5 again, it gives you 2, remainder 1, and 2 divides 2 divides 2, it gives you 1, remainder 0. Alright, so the whole number side gives us 1, 0 1 1 in base 10. Okay, as sorry, not in base 10, 1 0 1 1 in base 2, 1 0 1 1 in base 2 rather. Okay, and that is when we convert 11 base 10 to base 2. Okay, good. When we convert 11 base 10 to base 2, it gives 1 0 1 1 in base 2. All right, let's try to work out 0.6875. let's try to work out 0.6875, which is the fractional side of our outcome. Now remember, we said the method to do this is a method of continuous multiplication. Now we'll be converting the fraction, or rather decimal. You know, we moved from fraction to decimal. Okay, we'll be converting the decimal using the method of continuous multiplication. All right, and then this method involves this. Remember, we'll be converting from base 10 to base 2, and so we have 0.6875. all right, the active number multiplying will be 2 because that's the base we intend to convert to. And when you have this, you have 0.6875 times 2. Most times you'll be needing an add for these computations. And so I'll advise you use a calculator. Then you have 0.6875 multiplied by 2. It gives you another fraction altogether, which is given us you write on the other side, you have 1.375. okay, now what you do next is you pick the fractional side of your outcome, okay, and multiply again. Bring it to this side. 0.375 is the fractional side of the first outcome. Multiply by 2 again. So you have 0.375 multiplied by 2. It gives you 0.75. okay, you pick the fractional side again, and you have 0.75 multiplied by 2 again. all right, you have 1.5. you obtain 1.5. and when you look at this side again, the fractional side is 0.5. Multiply by 2 again. I need to adjust my line, and then when you multiply 0.5 by 2, that should give you 1, and then you have 1.0 without obtaining any other remainder. 1.0. when you get to the part where you have a whole number, you have to stop. And so the same method counts. You just need to pick your decimal numbers. And then we have 10 11 in base 2. okay, remember, this forms the decimal side of the fraction we just worked out. So which means bringing the two sides together. Remember that previously we obtained 10112 from the whole number side. okay, we will now add to the decimal side, and we still obtained 10112 from the decimal side. okay, when you add these both together, you have from the whole number side, you have 1011 to base 2, and then from the decimal side you have 1011 in base 2, which you can as well write as 1011.1011 and then all in base 2. Now remember that when it comes to continuous division, we start to pick our numbers from the last remainder, okay, to the first remainder. But when it comes to continuous multiplication, okay, we start to pick our numbers from the first to the last, not necessarily remainders, but they are whole numbers, the first digits that are obtained from your multiplication. Okay, as I'm cycling them, you can see 1, 0, 1 and 1. All right, this is all we have to talk about conversion from one base to another base. In our next class, we'll be talking about number base system and their basic operations. Number base systems and the basic operations. Thank you.